All right, so my background, just briefly, is engineering in Michigan, and got into the railroad business for 50 years. And in the middle of that, I went back and got a degree in structural geology at Idaho State. And I got into the speaking business about 2010 because we're due for a subduction zone earthquake. So people started asking me to give talks on that. So I've been doing that ever since. And then about a year ago, I got into the cruise business, and I've done 5 or 6 cruises, and got about 20 talks that I can give. I've talked to Tara about any of those you guys want to see, but that's my background. And I just want to start out with, if I can get this thing to go here.
I can do it on your leg.
Yeah, the mouse doesn't like the table. I don't have a pad, so if you do it on your leg, it finds it really easy.
Oh, that won't work.
You're just trying to change the screen.
Yeah.
Your clickers work.
Yeah, I thought it did too. It did a minute ago. So yeah, this is just a young playboy who's one of our seers that talks about very smart stuff. But you know, the idea that you guys are willing to sit and listen, and I just think it's amazing. Even as you start on your journey, being comfortable with moving beyond your old limits, it gives off a special energy, and it's just nice to have a lot of folks interested in stuff that's beyond your comfort zone. So that's one topic. We're going to talk about fossils in Alaska. This is part of the folklore up there, and I can't say that name. Anybody know how to say that name? It's because, yeah, Quaggar. Okay, this is a critter that lives underground, and if it gets exposed to oxygen, it burns. So that's the legend. And so I figured if I'm going to talk to paleontologists, you've got to probably run into this sooner or later. So watch out. All right, so yeah, so we're going to talk about Arctic dinosaurs. This is an idea that's a lot of these slides are from PBS Nova had a show on this. So if you see that, this is going to be somewhat familiar. But the idea that we're going to talk about this part of Alaska, and we've got 2 episodes where the Bering Straits were blocked by land masses over the years, and I'm a geologist, and so these terms, next one, Tara, these MYA and the YBA. I just want to explain the nomenclature that I use, and MYA is a million years ago, and then when you get closer to the present day, you switch to years before present. So just know that we have 2 episodes. We're going to talk about the first one, and if we have time, we can talk about the more recent one. But what I said we were going to do today is talk about the dinosaurs, and you guys know they all disappeared 66 million years ago. But so we're not going to talk about those in the near future. But this is where we're at. We're going to talk where 1 and 2 is located. That's up in what they call the Arctic Alaska terrain. And Alaska is composed of many terrains. These are land masses that have come into Alaska and formed the state. And the ones that are most prominent are the ones that are towards the north here. I'll go into that in a minute here. Go ahead, Tara. And this is where we're at. Next one. But this is kind of a snapshot of what we're going to deal with. They first found these Liscum bone bed was in 1961. And Liscum was up there looking around for oil deposits, and he found all these fossil beds in the Prince Creek Formation. And so he basically dug them out of the ground, and he cataloged them, and they put them in a repository there, and there they sat until 1984 when they started digging into this. And you know, you'll see that there's a lot more research going on right now. Next one. These are the critters that are up there, fairly unique dinosaurs as they go. The Nasquasaurus is this otherwise known as a polar bear lizard, and he's probably feathered as near as we can tell. Prince Creek Formation is where they're located, roughly either side of 70 million years ago. and the climate was slightly warmer than up there today. And when I first did this research, it was clear that that I was thinking more like 30 below, but it's a lot warmer than that, as I found out. I sent a note to Pat Druckenmiller, who's one of the key scientists here, and he basically corrected me on that. And there he is right there. He said basically it's more like you know, temperate climate around here or Boston. Say Boston's probably a little more apt because it's colder there in the winter. But the idea that it does get below freezing is what Pat assured me. So it's and the reason this is all up above the Arctic Circle, so we're way up north, and we do have 4 months of darkness there. So that's the thing that is still of some concern to these scientists. Next one. But this is how Alaska got formed over the years. Basically, it's you can see this is 400 million years ago, back in the Paleozoic. But the idea that you started over here by the Baltic area. And the reason they know that, basically, you've got these two terrains, the Farwell terrain and the Alexander terrain, and they migrated over through the North Pole, and you can see where the outline for Alaska is located here. So those things were basically launched about 400 million years ago. And next shot is, and they know this from the detrital zircons. You guys familiar with DZs? Okay, all right. So the idea, just briefly, the detrital zircons are pretty good for provenance and date, and they're long-lived minerals inside a lot of the deposits that are located, and you can trace these back. So it's really helped science determine where these rocks originated from, and so you can see where, yeah, it's fine to keep going, but the Farwell terrain moved on over, and then it basically went on through past around here, and it comes up the backside of Alaska is where the Farwell and the Alexander terrain. But this is where we're going to be talking about this Colville Basin in this Arctic terrain is where these dinosaur bones were found. This is basically, it got to that location about 70 million years ago. And at that time, there was actually a land bridge across that. Now, whether the dinosaurs came across that or not, I haven't ascertained which one they're going, but this is basically what it looks like from a broader view. You can see where the North Pole, this terrain, and where this 70 million year old dinosaur deposits are located is clear up there, way up north of the Arctic Circle. So it's way in an area where there's not much light. 4 months out of the year, there's no light whatsoever. There's a flip side of that, and we'll talk about that in a minute, but you can see that's how North America looked about 75 million years ago with the Cretaceous seaway. At the end, I've got Chris Scotese has got these models where they move the continents around. We can play with that at the end if we have time in the input. The climate is, you can see where the climate is here today, and then this terrain 70 million years ago was further north. And so I was thinking, you know, originally that we're down in this temperature here, but Pat assures me that the climate was a lot warmer there, and he thought that it's because of there's a fair amount of volcanic activity at that same time, and it basically warmed up the atmosphere in terms of a greenhouse effect. And there's a slide a little bit later that'll explain that. But it's kind of a deciduous area with some of the trees in that area were definitely more of the temperate climate, I should say. Next one. But this is kind of what, you know, Alaska looks like now. And when I first started this research, this is what I had in mind, but this is not at all what it was like for these dinosaurs. It was a lot more hospitable for them. Next one. But they started seeing dinosaurs down by Denali. They have these footprints that they found in the formation there, and these were a large dinosaur. And this kind of threw some of the original research that Pat and Greg did, Erickson. It said that these were kind of smaller dinosaurs, but these were clear, the big dinosaurs, the T-Rex, the big dinosaurs that migrated between Denali and the North Slope, which is about 400 kilometers. It's another picture of the same thing. But then this is some of the bones that they found in the Linscomb bone bed. And this was some of the bigger dinosaurs in that deposit. Next one. This is again the Prince Creek Formation. This Nanushuk Formation was it's characterized as being almost like Miami, almost tropical in temperate, and you can see where it actually it's cooler further up in the strata that you go. This is about 115 million years ago, and then the Prince Creek Formation is about 70 million years ago. Next one, and this is where they find all the dinosaur bones in these particular formations up there. Next one. But this is kind of the research that Druckenmiller did. He basically dug into the Linscomb bone bed, and they determined that this landmass was up around just north of where it is now, and so it's migrated slightly south. They started working in the summertime, and they found out pretty quickly that it didn't work to work in the summertime. So they ended up adjusting their schedule to work in March when it was only 30 below. And the reason being, next one, well, I'll get to the reason in a minute, but they found these smaller versions of the dinosaurs. And then at first they thought, okay, this is the dwarfism may be part of their evolution, given the fact that there may not be a lot of foodstuffs available. So that's part of what they're researching right now. Next one. But then they found this big dinosaur up by Denali, or down by Denali. So that's pretty much where they're trying to figure out where this dwarfism came from. Next one. Again, they found some unique, their fossils were such that they had a kind of a padded foot structure that would help them walk on the snow. So that's one thing they figured out, and that they had adapted to a low light environment. Again, 8 months of the year they've got sunlight, but 4 months of the year they don't. The flip side, in the summertime, it's 24 hours a day it's sunny. So the thinking is that the babies that came along there had to mature very quickly because they had 24-hour day to develop. The idea too that they have feathers, and the idea that they had to have something you know, that's going to get them through those cold periods, and they haven't figured this out yet. And you know, if you guys have any ideas, I'm pretty sure that they would like to hear them. But the concept of being cold-blooded, and if it's below freezing, and there's no light and no you know, they don't know really what they did. And there's some evidence as to the fact that they stayed up there. I'll get to that in a minute. But they didn't find, if we go back when there's actually no evidence of any cold-blooded animals anywhere in that strata that's up there. So they've looked for that. They've tried to find if there's anything that was cold-blooded, and they don't seem to find anything. Except, you know, the idea that the birds and the dinosaurs had to have some other way of keeping warm. So that's the enigma, and that's what they're trying to figure out. Next one, yeah. Yeah, it's just that they can't find anything that indicates any kind of cold-blooded animals up in that neck of the woods. This one was up there as well. It's a smaller animal, and they think that perhaps it burrowed into the snow or somehow was able to keep itself warm in that environment. And these are quite prolific up there. Next one. Yeah, and so like I said, at first they tried working in the summertime, and this is a shot of that, and you can see the Prince Creek Formation and the permafrost in the background there. It was pretty easy digging, but the problem was, next one, is that permafrost, it turned out to be extremely dangerous to work there. And they'd be working, and let's go back one. So they would be working on these bluffs in there. And one of these beds is quite prolific, is the one that they're finding all the dinosaur bones in that. But they were worried for their lives because this stuff in the summertime would melt and it would come down on them. Not only that, the mosquitoes were so prolific that they carried them away. So they decided that the better time to work was in March when it was 30 below. They could handle that. Anyway, next one. But this is a shot of their campground in the Aurora Borealis in March when they would get up there. Then they'd run snow machines into that location. And this is some of their work that they worked on the permafrost. Permafrost is it's like rock, and so they weren't able to make any. There was certainly an advantage to working in the summertime because they could get the rocks out of there, but it was at a high risk of their lives, so they opted to work on getting these bones out in the permafrost. And this is one of the sites where they were using pneumatic drills to dig into this stuff, and they would take out these big chunks, and then they would carry them down to their snow machines, and then they would take them back to camp, and then they would take them on into University of Alaska there at Fairbanks to do basically the reduction. So this is on their way back out of where the deposits are. So it's a nice commute, right? Yeah, so this is what they would do. They would take all these bones, and it was just a mesh, and they would basically put it through a process where they would pull out all the dinosaur fragments. And this is the kind of evidence that Pat and Greg were working with. And they found in this evidence, they found a lot of this perinatal, these baby dinosaur bone fragments in the bone deposits there. And then so they realized that the babies had to be born early in the spring there, and being the babies, they weren't likely to be able to walk very far. They would have to basically the babies would tie them down to a location. So what they're thinking right now is that they stayed year round up there, and that's the thing that's really got them confused, because they haven't figured out a mechanism to how these dinosaurs could live for 4 months in the dark. And so this is kind of what we're talking about up there in the upper left, is where the bones were found. And maybe they could migrate 500 miles is what that short arrow is. And then the long, that's 2,000 miles to actually get to where there's light. They don't think they did that. So that's the logic behind their research, is to try to figure out, what did they eat and what did they do during that whole time they were up there. So they were actually looking for any advice from you guys. So give them a call. All right. And this is kind of what our rendition of what they think the climate was. It certainly had snow around, and certainly had the kind of conifers and deciduous trees that we have around here, or say Boston, someplace in kind of the not the warm climate, but not cold either. It was basically, it was around, you know, in the winter, it'd get 28 to 30 degrees Fahrenheit. Would be about as cold as it would get. But this is, again, what they were dealing with up there. And then again, they would be in this condition when the winter would come, and then the light would go away. So what they ate for food is something that's also they're trying to figure that out. Next slide. This is kind of the temperature gradient. Again, this is where the was warm in the late Cretaceous, and then it cooled off, and this is where we're talking about. And the temperatures over here in this, go back one, right in this area here is where we're at. So it's definitely in the cold, and they definitely had to have snow in there. They think that's a fair amount of Arctic terrain in there based on the padded footprints that the dinosaurs left. Next one. Then this is kind of what they're thinking the temperature was. So that's you know, while it's a lot warmer than 30 below, it's still something that if you're cold-blooded, you got to figure out a way to get warm and stay warm, and that's what we're trying to figure out right now. Next one. Again, another shot of what it looked like there. Again, not tropical, but not you know, tundra either. So it's somewhere in between. Again, this is some of the research there that talks about you know, as bleak as the winters would have been, they still they would have had in the summertime pretty good incentive to develop with a 24-hour sun as opposed to the darkness. So basically, there's some benefit that they may have had enough time for the dinosaurs to lay their eggs in the spring, and for these little babies to get enough you know, fat and protein stored up so they could survive a winter up there. Next one. And again, this is some of the research on top of the fact that they had rain and snow up there, and the idea that it was kind of a polar woodland that lacked ground ice is what this research says. Next one. And just another synopsis of the type of terrain that was up in there and how cold it was. Next one. But you know, so that's pretty much the beginning and the end of this topic. And if you guys had some ideas, I'd like to hear them, because you know, I don't think the two scientists involved haven't gone much further than this. And so in terms of the research that Greg Erickson, he's out of Florida, and then Pat Druckenmeier is out of Alaska. They're at Fairbanks. They're still deep into this research. Next one. One more topic I did want to share with you is you know, these dinosaurs were living here at 70 million years ago. And I was talking to Tara. She said that you guys heard her talk about the Chicxulub asteroid impact at 66 million years ago. So they didn't have long to live up there. So 4 million years, and then right here at 66 is when the asteroid hit. And that's another talk I give. Next one is basically, you know, whether it's an asteroid impact or the you know, the volcanism that hit basically on the antipode of the Earth. You know, if the asteroid hit here, and the almost the same time, the Deccan volcanic traps developed, the large igneous province, basically on the other side of the Earth at the same time. That's got to be more than a coincidence. So that's why I put the fact that perhaps those are two related. If you do the math on that, just if the asteroid hit at an angle, it's actually about where the Deccan traps originated. Next one. And then so basically the dinosaurs disappeared, and the next critters on the scene 70 million years ago. or, fast forward 70 million years, and now we end up with these guys here about 18,000 years ago. With that, I'll open it up for questions, and thank you, guys.
So if we're asking here, question.
Okay.
My first thought is you mentioned some of the migration. Little ones might not be able to migrate more than 100 miles, but the big ones migrate quite a ways further south into that non.
Yeah, the thinking was, yeah, if they were the big dinosaurs, yeah, they could walk that far. Yeah, but the little ones, that's where Pat gets stuck. He says he doesn't think they go that far. They don't have enough body mass to make it down there. And the caribou, they do that too. They wander all through here. But they're wandering about that far as well.
So you say they have no cold blood, so I assume that means there's no crocodiles, no alligators, no turtles, none of that kind of stuff.
All right, they're pretty clear about that. No frogs, nothing, no amphibian life whatsoever. They found no evidence of that, but they can't figure out just the mechanism by which these dinosaurs, lived. If they're truly cold-blooded, or maybe it's some sort of hybrid system that we really don't know about yet, but something was keeping them warm. They were too big to burrow down into the ground like those dinosaurs could do that, but not the big ones.
Were all the dinosaurs they found herbivores?
No, they were both carnivore. Yeah, they were meat eaters and then plant eaters. They were all mixed in there.
Oh,
Right. But even, but in the cold, in the dark, nothing's gonna grow. So that's, yeah.
What about ornithischian versus saurish?
Pardon me?
Like the bird dinosaurs versus the reptile dinosaurs, the ornithischians, are they more bird ones?
Well, they do have bird dinosaurs up there, yeah.
But they have both?
Yeah, that was some of the assemblage in that melange of bones that they found. They just said there were 12 dinosaur species. I didn't look into which was which. Yes, sir. Oh, okay.
They were compared to formulated and I thought showed that were not.
Okay. Okay.
Question.
Yeah, the question is, a gentleman in the audience said there's some research done on leg bones that indicate that these had to have been warm-blooded as opposed to cold-blooded. I haven't heard that, but that sounds, that would make sense.
They're warm-blooded, perhaps they could hibernate.
Right.
Also, we don't know anything about their skin covering, so this thought possibly be marsupial.
Right.
Carrying
The idea that they could be marsupial makes a lot of sense in terms of the and the idea that they could have been feathered is just conjecture on the researchers that have, yeah.
So you know that some of them were skin impressions that also show feathers.
So yeah, there's a lot of evidence that there are feathered dinosaurs in
The question is, how feathered were they?
these ones, yeah. Yeah.
As far as I know, they have no feather imprints from the Alaska vaccine.
Yeah, that was just gonna, yeah, that's,
There's no positive proof that the Alaskan dinosaur species had feathers, but we do know that contemporary dinosaurs in China did that.
Can you compare the Alaska dinosaurs to the Antarctica dinosaurs?
No, I didn't do that. Yeah.
That was my question. Compared to like Carnosaurus or something that is an Antarctic dinosaur.
That's your next talk, or that's your next talk. Yeah, the question is, are there Arctic, was there a comparison made between Arctic dinosaurs and Antarctic dinosaurs? And the answer, you know, I didn't do that comparison, but it sounds like somebody should. Yeah.
It does.
Yeah, well, yeah, there's dinosaurs now. Yeah, finally, yeah.
Yeah, these are just up north, yeah. Way
So
up north.
with the thing to consider with the Antarctic stuff is, so we mostly know of dinosaurs from the Jurassic, and we do have some Cretaceous fossils, Cretaceous dinosaurs from Antarctica as well. But Antarctica hadn't split off yet from the rest of Gondwana. So it's still, you know, so, well, let me start over. During the Cretaceous, it is southern hemisphere, but it is not as far south as it is today, and there isn't a southern current around the continent forming year-round ice yet. So just one thing to keep in mind. Yes, it is further south, but it's not definitely not the same as what we think of Antarctica today.
But yeah, I mean, the one question that it wasn't the 30 below type temperatures is what I was originally thinking that
Yeah,
Oh yeah, and I'm talking latitude. I mean, so yeah, temperature wise too, but I'm talking specifically about latitude.
yeah.
Yeah, so it would have been warmer in for the Antarctic.
All right.
Cool. Thanks, Mackenzie.
Any other questions from a Zoom audience?
Yeah, I have a Harold Hines here. This is the second time this group has heard this presentation or a variation on this. And it seems to me that it's not much has changed since we heard
Oh,
the
okay.
earlier presentation. But one thing that I wonder, to what extent was, so there was it was cold enough so that there was snow on the ground.
Right.
But was the ground completely covered with snow, or are we looking at an environment in which we have extensive open terrain in which there's grazing, even though it's winter?
Yeah, those photos I showed, it did, or artist renditions did show a ground cover that was maybe 50% snow and 50% snow free. So it's hard. It's just a guess on our part at this stage.
Well, so in that area, given the long summers with all the sunlight you have a very rapid vegetation growth. And so there's a lot of foliage that might have been available throughout the winter for grazing.
Yeah, that's
Yeah, see it, they have to have good, I agree.
yeah. Yeah, it'd be difficult to see in the darkness, or I think the conjecture is that their eyesight was adapted to low light environments. But if it's dark, it's dark. It's yeah.
You have a roof light?
Well,
You could have
lots of animals manage to graze in the dark.
the moon.
Yeah.
Wouldn't necessarily be at the same latitude or same elevation of the sky, same. That's what sort of.
So with Harold's comment about grazing, the C4 grasses, which are warmer, those don't come along until the Eocene, and they take off in the Miocene. They really start to take over the Miocene. For grasses or grazing like or plants that animals could graze upon, we don't really know what those would be. There could be phytoliths that might indicate that up in those sediments. I don't know if the Stromberg lab has looked at those yet, but that's where that evidence would have to come from. Would be from phytoliths.
There are two questions.
Okay.
What cruise line do you lecture on?
The question, which cruise line?
Very-
Yeah, Princess, Silver Sea and Viking. And it was the Viking that cruise that they wanted to hear about critters.
And Logan Greenwood is saying, I'm sure other people have considered it, but it is possible that the dinosaurs went through some sort of brumation or torpor. Hibernation kind of thing.
Torpor is like when the fish are at the bottom of your pond and they sit there and they breathe once an hour.
Hummingbirds do it.
I mean, yeah, hummingbirds
Yeah.
too. Yeah.
If the adults can do it, maybe that's possible, but I'm not sure the babies could do that. I don't know. Yeah, and that's the thing that's kind of tied, Pat, to the fact that these babies that was probably the limiting factor. And certainly if the babies were gonna make it, they weren't gonna make it as a species, but
8-month-old. Maybe they grow fast.
Bears do, right? Bears that are
Maybe,
8 months old.
maybe if right after the dark, right when the sun starts appearing, that maybe that's breeding time.
yeah,
And then you have 8 months for them to go, 6-month-old. Pretty big dinosaur. I don't know,
yeah.
6-month-old dog's pretty big.
But, I've got Pat's email. He was pretty receptive to any of your ideas. Oh, is he? Oh, okay, all right,
Present some, but not saying he did.
okay.
They try to look at like lines of wrestling, but it's just. Question would be, is actually making it the whole year, making a lot of job. Because that's me would be, oh, we made it a whole year, now we're starving. Here's our hard line.
Yeah, I'm not sure I got, yeah. It's just what happens when they wake up from the 4 months of darkness?
Yeah, that, if you have, bone grows, if you have a dinosaur that was growing, line of rusted growth, normally like in a tree. You have one-
Oh, I see. Yeah, is there some way of demarcation each seasonal advance in terms of?
If you have no food, then they're basically starving. Without bone growing at that time period. The question would be, can you determine the length between lines of
Right.
rusted growth or not?
Yeah, do you see like trees in rings on a tree, do you see bone growth that's dependent on seasonal patterns?
I mean, that's how you're looking at T-Rex and things like that, but what
Right.
the seed lines and rusted growth. That would be.
Yeah. Yeah, that's a great question. I don't know that answer.
Yes, that's actually one of the lines of evidence for endothermy in dinosaurs are the growth rings in the bones.
Okay, thanks.
He's learned something. Yeah. So the guy that keeps coming up, FYI, he started with our club when he was 14 years old.
Okay, good.
And he's worked his way up to a PhD in paleontology and went to the East Coast now.
Oh, neat.
So,
I'm glad to have you. Yeah.
Logan asked another question. Did the possible grazers have hypsodont teeth or something similar for the grit and snow?
And what type?
Hypsodont teeth are ones that erupt like horses, so they grind over time. And
So
so they keep,
Continuously come out.
yeah, they're just always coming out. And so it allows them to eat grit or whatever to grind things down. That's typically with the horses, if they develop the ability to eat grass because of the vitalists, as Mackenzie was saying, is in there grinding it down. I don't know if you're gonna find that much sand.
This is a lot earlier, right?
Yeah.
This,
Yeah,
hypsodonts,
so it would be.
mammoths.
Yeah, this is, yeah, this,
All before, wouldn't say you couldn't do it.
Well,
Interesting. Yeah, they were more. Yeah, they're growing on trees and shrubs, things like that.
okay, that's it here.
well, thank you guys.